Today, we are gonna learn about the trigonometry. So let's begin with a very simple story. Suppose you enter your study room to start with your studies, but as soon as you enter the room, you realize that there's a power cut. So you take out your flashlight and switch it on. As you switch it on, you see a spot of light on the wall opposite to you. Something rattles your brain, and now you end up asking a question to yourself. Is it possible to measure the distance between the spot of light and yourself? Given that it's a straight line, I believe it's easy. And then maybe, just out of curiosity or fun, you tilt the torch a bit. The next thing you observe is that the spot of light crawls up the wall to a new position. Now you wonder if it's possible to measure the distance between the two spots of light. But as you do so, another question pops up inside your head. What about the amount of rotation given to the torch? Is it possible to calculate the amount of rotation? Well, trigonometry is all about the measurement of the amount of rotation, which is also known as angle, and the sides with respect to each other. As soon as the power comes back, you draw a ray diagram on a piece of paper to observe and analyze the situation in a much better way. So you draw two mutually perpendicular lines, as in the x-axis and the y-axis, thus keeping the torch at the origin. Trying to give the torch about the same amount of rotation, you observe that a right angle triangle forms, where OP can be assumed to be the base of the triangle, QP as the perpendicular, and the ray OQ as the hypotenuse of the triangle. Now, deprived of an instrument to measure the amount of rotation or the angle directly, you observe that the side QP is proportional to the angle. As the amount of rotation increases, so does the side opposite to it, with the ray OQ also changing its position simultaneously. With that idea of sides of a triangle depending upon the opposite angle, we now understand that the amount of rotation can be measured with respect to the sides of a triangle. So by a convention, we use sin theta as PQ upon OQ and cos theta as PO upon OQ and tan theta as PQ upon PO. With that idea of indirect measurement of the amount of rotation, we can use another method where we draw a circle of a unit radius, and from its center we draw two mutually perpendicular lines. Keeping one axis fixed, we rotate the other. Let's say the x-axis in this case. We again observe that a right angle triangle gets formed after the line is rotated by an angle theta. Now if we draw two perpendicular lines, one on the OP and the other on the y-axis, we end up with a right angle triangle. Now that we are talking about right angle triangle, why not just draw one containing an angle theta? Now from here, we can see that sin theta is basically perpendicular upon the hypotenuse. Cos theta is equal to the base upon the hypotenuse. And tan theta is basically perpendicular upon the base. Now that we have the three fundamental trigonometric ratios, we also have their reciprocals, as cos theta as the reciprocal of sine theta, where we have hypotenuse upon perpendicular. Similarly, sec theta, which is the reciprocal of cos theta, and thus we have hypotenuse upon the base, and cot theta, which is the reciprocal of tan theta. So we have cot theta as base upon the perpendicular. Now that we have got 6 trigonometric ratios, why not put them in a tabular form and see them all in one slide. Sine theta is perpendicular upon hypotenuse. Cosec theta is hypotenuse upon perpendicular. Similarly, cos theta is basically base upon the hypotenuse, and sec theta is hypotenuse upon the base. Similarly, tan theta is basically perpendicular upon the base, and cot theta is base upon the perpendicular. Now that we are talking about a right angle triangle, how can we miss the Pythagoras theorem? So here we have a right angle triangle containing the angle alpha. And as we know, the Pythagoras theorem, which is an integral part of a right angle triangle, which is p square plus b square is equal to h square. So in the first case, what we are gonna do is we're gonna divide the LHS of the Pythagoras theorem and the RHS by hypotenuse square. And when we do so, we get p square upon h square plus b square upon h square is equal to h square upon h square. So we get p upon h whole square plus b upon h whole square plus h upon h whole square. As we know, p upon h is sine alpha, b upon h is cos alpha. So we get our first trigonometric identity, which is sine square alpha plus cos square alpha is equal to 1. Now let's write the Pythagoras theorem once again, which is perpendicular square plus base square is equal to hypotenuse square. Now in this case, let's say second case, we divide the LHS of the Pythagoras theorem and the RHS by p square. So we are getting p square upon p square plus b square upon p square is equal to h square upon p square. P square upon p square is 1, b upon p whole square is equal to h upon p whole square. As we know, b upon p is equal to cot alpha and h upon p is cosec alpha, we end up with a second trigonometric identity, which is 1 plus cot square alpha is equal to cosec square alpha. Now let's write the Pythagoras theorem once again. P square plus b square is equal to h square. So in this third case, what we are gonna do is we're gonna divide the LHS and the RHS by b square. So p upon b whole square plus b upon b whole square is equal to h upon b whole square. So here we end up with a third trigonometric identity, which is tan square alpha plus 1 is equal to sec square alpha. Now that we have derived 3 fundamental identities from the Pythagoras theorem, we arrange them in this 3 trigonometric identities, which is sine square alpha plus cos square alpha is equal to 1, 1 plus cot square alpha is equal to cosec square alpha, and tan square alpha plus 1 is equal to sec square alpha. Let's have a question. What if sine theta is given to us as 3 upon 5? Now we know that sine theta is perpendicular upon hypotenuse. So once we hear of perpendicular and hypotenuse, we end up drawing a right angle triangle. And from the given information, we know that the value of perpendicular is 3 and the value of perpendicular is hypotenuse is 5. So we use the Pythagoras theorem. Since we are dealing with right angle triangle, p square plus b square to h square, we put the value of p as 3 and h as 5 and then solve the equation, and we get a b square as 16. So we end up with b as 4. So we get a base as 4. Now that we have got a base as 4, we can use another ratio, that is cos theta, which is b upon h, and we end up with cos theta as 4 upon 5. Similarly, we can use tan theta as p upon b, and we get the value of tan theta as 3 upon 4. Now that we have got the value of sin theta as 3 upon 5, the value of cos theta as 4 upon 5, and the value of tan theta as 3 upon 4, can you guys tell me what will be the value of cosec theta, sec theta and cot theta? So I want you guys to write down your answers in the comment section below. Let's have another example where cos alpha is given to us as 4 upon 5. Now, what we can do is we can use our identity to solve this question. So we use our fundamental identity as sin square alpha plus cos square alpha is equal to 1. And since the value of cos square alpha is given to us, we get to solve the equation in the following order, and we end up with sin alpha as root over 9 upon 35, which gives the result 3 upon 5. Now that we have got the value of sin alpha, we can also get the value of tan alpha, which is sin alpha upon cos alpha, and we end up with the result 3 upon 4. Now that we have the value of cos alpha as 4 upon 5, sin alpha as 3 upon 5 and tan alpha as 3 upon 4, can you guys tell me the value of sec alpha, cosec alpha and cot alpha? So I hope you enjoyed this lesson. Thank you for watching and have a good day.